Since last semester, Team 14 has been hard at work developing the modifications to the Arizona Foundation Solutions moisture level system. Based on feedback received at the end of last semester, Team 14 spent the winter break researching cheaper alternatives for some of our components. These alternatives were then presented to AFS when school resumed in January. Because of this, the team was delayed in ordering parts, and some of our parts were then further delayed in the ordering process. To make up time, Team 14 reviewed our Gantt chart and combined and rearranged tasks in order to meet our deadlines for the end of the semester. We are now back on track. Dan is currently working on the programming, while Brett, Ben, and myself are working on the installation and testing procedures so that we are ready to test the full system once Dan is finished. We will begin full system testing after our March 16th presentation, giving us plenty of time to revise and retest before demo day. For the purposes of this video report, Dan will be explaining what he has done as far as programming and preliminary testing. Ben will be discussing the testing procedure that has been written for the startup and integration phases, and Brett will wrap things up with the installation procedure. I will now turn things over to Dan.
We'll be going over the programming of the PLC and preliminary testing. The coding of the PLC is being done with the Arduino IDE and consists of a variation of C and C++ coding. The coding is being performed in blocks at a time, starting with the humidity sensor, then the conditional statement for the relay to operate, followed by data login, and lastly Wi-Fi connection. At the completion of each block, the code is compiled and debugged as necessary until desired operation is achieved. Currently, coding of the data login block is currently taking place and is expected to be completed shortly. This block is extremely important because it allows for trend analysis of the system and shows whether the system is operating as expected. Part of the code is the conversion factor for the humidity probe. This code is part of the humidity sensor block and is essential for the humidity sensor accuracy. Testing of the humidity probe will be done with a third-party humidity sensor. If the PLC humidity matches that of the third-party humidity sensor, the code will be called satisfactory. If not, the manufacturer will be contacted and our calibration graph will be used as necessary to tweak the conversion factor to match the third-party sensor. This is allowable because the humidity versus voltage plot is linear. I will now turn things over to Ben to cover the testing procedure.
I will be going over the formal testing procedure. The first test is a startup test and with sensor accuracy. To verify the accuracy of the sensors, the reading of each sensor will be compared with the accepted value obtained using the Hygro mobile app. This app uses location information to determine the relative humidity level based on weather service data. The next one is the pilot lamp test. Prior to integrating with the entire system, the system automation will be tested for 4 different input configurations. This will be accomplished by replacing the exhaust fan with a pilot lamp in the wiring diagram. From there, the team will test the system response for the following 4 configurations. Number 1 is when both sensors are off. Number 2 is when sensor 1 is off and sensor 2 is on. Number 3 is when sensor 1 is off and sensor 2 is on. And then number 4 is when both sensors are on. The on state corresponds to humidity reading above 12%, and off state corresponds to below 8%. The second type of test is the integration test. Aesthetics and overall fit. We will make sure the entire system will fit in the approved testing location and size of the box that we have. An appropriate size for the fan box, if different from existing, will be specified. We then have the full systems test. This stage of testing is identical to the pilot lamp test with 2 exceptions. First, the exhaust fan will replace the pilot lamp. Second, the functionality of a manual override switch will be tested for a normally on and a normally off condition. We then have the data analysis, which the fan run data will then be exported for company evaluation.
To accompany AFS's new PLC control system, we will also be providing them with the installation procedure. This installation procedure will cover the interior and exterior installation, from producing the suction pit, installing the new humidity sensor, and the piping that runs to the fan. From there, we will have to modify to include a second humidity sensor and the installation of the PLC in the fan housing. We will also provide them testing procedure, wiring diagrams for the new control system, installation diagrams to make sure everything is properly placed in the fan housing to produce an aesthetically pleasing design, and the complete code for the PLC to verify it's correctly coded prior and following installation. Thank you.